Welcome to MyProjectBazaar.com. Let we discuss about the process DWT based feature extraction for iris recognition. Let us see the abstract of the process. Individual recognition using iris is most commonly employed in all the places. This requires some special cameras to take iris image, and the obtained iris images were classified based on the features extracted. Only identification of the person is not the application of iris recognition. It can be developed into many processes. The iris image captured from the cameras were taken. Individual recognition system using iris is done based on the following process. In the proposed approach, the process of recognition of the persons based on iris image is done by extracting DWT features from the iris image. The DWT features were the statistical features extracted from the input images. The extracted features were optimized based on genetic algorithm. The genetic algorithm process includes selection, crossover, and a mutation process. The probability of the selection of the selection of the features were estimated in the selection, crossover, and the mutation process. The optimized features were then used for the matching of process based on equivalent distance measurement. Before the extraction of the features, pre-processing of the iris images were employed based on the smoothing process and the edge detection process. The pre-processed iris images were then normalized. The normalization process identifies iris and the pupil region in the input images correctly, and it reshapes the identified positions. The normalization process improves the efficiency. The process of application of the optimization techniques helps in the reduction of the features counting. The person to whom the input iris belongs is identified, and with the help of the identified person, the matching process is employed. The performance of the process is measured based on the performance matrices. The performance of the process indicates that the proposed approach is more improved compared to the other existing approaches for iris recognition process. Let us see the flow of the process. Input iris images were obtained from the dataset. As input, we select two images from the user. We obtain two images from the user. For each image, the same process is repeated. The first step is the pre-processing process. Input iris images were obtained from the Cassia database. The images were in different sizes, so the images were commonly resized to 256 size. The images were then filtered using median filter process. The median filter smoothens the noise from the input images. The images were divided into small regions, and then the noisy pixels were identified in the regions. The identified noisy pixels were then replaced with the help of the average value of the overall regions. After the pre-processing step is the edge detection process. For the detection of the edge regions in the images, canny edge detection process is employed. Canny edge detector is an edge detection operation that uses multi-stage levels to detect wide range of edges in the images. It uses filters based on Gaussian filtering processes. After that, the iris and the pupil detection is done. For iris and pupil detection, circular half transformation is applied to the input images. Finally, the features were extracted based on the wavelet coefficients. The input images were decomposed based on discrete wavelet transformation. The transformed regions were split into four different coefficients. The average value, standard deviation value were extracted from the obtained portions, which is used as the features for the process. After that, the extracted features were optimized using genetic algorithm, and hence the number of feature values were reduced. Finally, the selected best features were used for the similarity matching process. The similarity matching process is done based on the calculation of the distance between the features extracted from the images. If the distance is minimum, means then both of the images were the same, and we can say the input person is authenticated, or else the input person is not authenticated. Let us see the running procedure of the process. If you want to run the code, select the file main.m, which is present in the dataset folder. Right click it and click on run file. You will get the process executed. So first select any one of the input image which is present in the dataset. After that, this is the first image that we have selected. After that, give the second image. So we have given the second image for the process. So after we have given the second image, the process will get executed. So this is the first step, that is the resizing step. So the images were resized. So this is the smoothing step, which is applied based on the median filter. This is the canny edge detection process applied to the image of level 1. This is the canny edge detection applied in the level 2 step, and then this is the level 3 step. So this canny edge is applied from 3 levels, and each of the edge detection process is displayed. This is the gradient image of the first and the second image after the hysteresis thresholding. This is the gamma correction image applied for the first and the second image. This is the image obtained after the hysteresis thresholding. This is the circular Huff transform process, which detects the iris and the pupil regions in the input images. This is the normalized iris image of the first and the second one. The detected iris regions were normalized, that is, they were converted from Cartesian to the polar coordinate. So this is the input images that we have given. So these two images were not matched since the distance between the images were not minimum. The features were extracted from the images based on discrete wavelet transformation, and the genetic optimization process is done. So this is the genetic optimization process for the first image, and this is the genetic optimization process for the second image. So these are all the fitness values estimated for the two features, and the two images were not matched. Finally, the performance of the processes were measured. So these are all the performance measures that we have measured: false acceptance rate, false rejection rate, total successive rate, and error rate. So these values were measured for the input images. The extracted values were represented in a graphical format. These values were plotted statically. The performance of the process is thus compared. As we can see, the proposed approach is more effective since we have reduced the number of features extracted. The number of features extracted using DWT is very large in numbers. They were much reduced, and based on that, the similarities were measured, and hence the performance values were improved.